Okay, today's tutorial is moving on from rectangle collision detection onto distance-based collision detection. If you remember from the code we created before, we created a very simple XNA collision detection routine that allowed us to identify that when two rectangles overlapped, that there was a collision. And as you can see where we demonstrate here, the problem with rectangles, particularly with circular type objects, is that you have a massive great gap because the corners of the rectangles overlap very easily even though the images haven't, meaning we can't even get through the gap there. So that's pretty rubbish for this type of example. You can see it's not going to work very well. Now, there's a couple of things you can attempt to do with that. One is you could adjust the size of the rectangle so it only covered part of the circle, or the other is that we could use distance-based collision detection. Again, distance is very good for circular objects, but it's not going to help you if you've got a rectangular one, so don't use this if you want to do rectangular collision detection. So how does it work? Well, if we have a quick look at the image that I've created before, it's come from my slides from my course. When we want to do distance-based collision detection, if we look at this, this is basically the same principle as the two things we've seen on the screen colliding. Now, each of our circular items have radiuses that represent the circle that we could use for collision detection. So if we look here, here's two images overlapping. The distance between there and there is a way of us deciding whether or not something's collided or not. So if we add radius 1 to radius 2, right, so the radius of maybe your moving player against a block that's of a circular type, if we add those two radiuses together, as soon as the distance between the two centre points of these two circles gets less than the total of those two radiuses, we've got a collision. So we can actually achieve that through the use of some of the XNA features that we've got, which vector2.distance is a way of measuring two positions and seeing how far away they are. So what we want to do is we want to take our player position and put it against our enemy or block position, okay, and measure those two distances. What we're saying is this is the centre of our graphic for our player, this is the centre for our object that we want to see we're colliding against. Okay, when we do vector2.distance, we basically measure that distance between the two items. And then we can do a simple mathematical addition to add the two radiuses together and compare it against that distance. So that obviously works very well with round objects, and it makes rotated collisions better as well, because a circle, as you say, is rotated, it doesn't matter. It's not perfect, and don't use it if you try to work with rectangular shapes. Use a rectangle if you want to do that. Intersect is fine for that. Okay, so how do we actually achieve that? Well, first thing we do is, let's close our code. First thing we need to do is, for each of our classes, for static block and for player, we need to give them a new property or a new variable. Okay, radius. Okay, so that's player updated. Save that. Not being used at the minute. Got to give it a proper data type. We use integer because we're only working in pixels for this. If you were working with 3D coordinates, you might want to make this a float. We do the same for the static block. Okay, so public, just want to be able to modify it. Integer, radius. Okay, so at that point we've now got the ability to set the radius for both of these two things. So if we save those up to date. So let's, in our XNA game, just add in some measurements. Now, the image that we're using is trim saucer. Alright. The only reason we're using trim saucer is because if you look at single saucer, it's got a little clear border around the outside of it. Realistically, if you're going to do collision detection, you need to get this cropped down to as small as possible. So we've trimmed it down. Now the dimensions of our image are 54 by 54 pixels. Okay, so if we divide 54 by 2, that's going to give us 27 as a radius. So we'll just update all the radiuses for these things. They're all the same size conveniently, so that saves a bit of typing. Notice radius now appears because we've added that as a property, equals 27. Okay. And then if we repeat that for block A and block B. Okay, now the obvious thing to say is that, you know, we're using equally sized sprites at the moment. Everything's the same image. If you were working with different sized sprites for your game, you'd have to adjust the radiuses to the same sizes as your images. Okay, now that what you're normally doing, to be honest, is you're actually just opening that up in an image editor, having a look, making a close guess to where you want it to be. It's not that difficult if you measure horizontally. So if we save that, we've now got all of the details that we needed from what we were doing before. You looked at the diagram, you saw that there were 2 circles and they had 2 radiuses, and you needed to total them. So in actual fact, to work on what we were doing before, static block was the most simple bit of collision detection we could do, rough collision. So what we're going to do to change this is actually to remove rectangle intersections, and we're now going to do our distance calculation instead. So in the slide it looked as though you could do it as a separate variable. I'm going to do it all on one line just to keep it simple. So vector2 has a method called distance. Okay, and our 2 sprites have locations on the screen held by position. So our player sprite has a position. Okay, and if you remember from before, we're iterating through all the static blocks. So if we now do block position. Okay, so they're the 2 center points of our block on the screen. So as we're iterating through these, block gets updated every time with the next item in the game components collection. Now, what we want to do is when that distance becomes less than the 2 radiuses, so here's our player radius for a start, plus block radius. Okay. At that point, our radius plus that radius, once we get below that value, we've actually got a collision. So if we run that again now, here's our circle. Now our problem before was diagonally, if we hit that we would have had a collision, but now you can see it's very, very accurate in terms of where we're hitting. Alright, and now, whereas before we couldn't even navigate between those 2 things, we can easily get around them and circle around them. Okay, so that resolves a lot of problems that people have with their games. Now, we're not going to do it in this tutorial because there isn't sufficient time. I prefer to keep my tutorials down to at least 10 minutes if possible, maximum 15. So there is another way of doing collision detection which is very processor intensive, and it's very accurate because it works on every single pixel on an image, which is called per pixel collision detection.